Hi everyone, welcome back in lecture number 5 of our course CNC Machining Programming, and in today's lecture we will do program for turning cycle by using code G90. So as we know that G90 is the G code or a preparatory function which remove the material from the workpiece, and the function and meaning of this G90 code is box turning cycle or simply turning cycle. Let me explain you this turning cycle to you in a detailed way. This cycle is used for stock removal in parallel toolpath, and this cycle performs 4 distinct moves with one line of information. So this is the key point over here. When we will use G90 code, then it will execute 4 distinct moves with just one line of information. And the 4 distinct moves are mentioned here. The first move which it will execute is rapid to X position. Second is feed to Z position. Third is feed to start X position. And the fourth move which it will execute is rapid to start Z position. Now, in order to understand this, let me take an example of a cylindrical workpiece. Let us say this is a cylindrical workpiece. And initially the workpiece will be just like this. And we are interested to remove this much material from the workpiece. We also know that initially our cutting tool will be at its home position. So let me draw the home position for you. So this is the insert of the cutting tool, and he is at its home position. Home position is also called as machine coordinate system, MCS. Now we have an option to move the cutting tool from its home position to this particular point or to this particular point. Now, in order to understand all these 4 distinct moves, let us say we are moving the cutting tool from this home position to this point. And this point is, let us say, it is point number 1 or starting of the point. Okay, or X position, start X. So in order to understand X and Z, let me draw a work coordinate system over here. We know this will be our Z movement of the cutting tool, and this will be X movement of the cutting tool. So when we are moving in this direction, that is in vertical direction. So this is our X movement of the cutting tool. And when we will move in a longitudinal direction or in horizontal direction, this will be our Z movement of the cutting tool. Now, in order to remove the material from the workpiece, now we are moving the cutting tool from point number 1 to 2. As there is no contact of the cutting tool here, you can see, so we will provide here rapid movement to the cutting tool. So this is the meaning of this first move or first line, rapid to X position. So when we are going from point number 1 to 2, we are providing rapid movement to the cutting tool. Now, from 2 to 3, let us say this is point number 3. When we will move the cutting tool from 2 to 3, we will give some feed to the cutting tool because we are removing the material from the workpiece. So this is feed to Z position because we are moving in a longitudinal direction. This is our Z movement, and Z represents the length, as we know. And X represents the diameter. So now, after that, now we are moving from point number 3 to 4, let us say, again with some feed. Why? Because we do not want that our cutting tool may break the edge of this workpiece, because that will lead the part to the rejection. So in order to keep the part safe, we will provide some feed to the cutting tool when moving from point number 3 to 4. So this is feed to start X position. So this is the start X position diameter value. So this is the meaning of the third line. Now the fourth move which it will execute is rapid to start Z position. It means now from point number 4 to 1, it will move with rapid traverse. Because there is no contact of the cutting tool here, you can easily see here. So we will provide rapid movement with the cutting tool. So this is the G90 cycle where it will execute 4 distinct moves. So let me just explain you this, that how our cutting tool will move here. The cutting tool will start from this point number 1. It will go from point number 1 to 2 with rapid traverse, then from 2 to 3 with some feed slowly, and it will remove the material. Then 3 to 4 again with some feed, and 4 to 1 with rapid traverse, and it will stop here. Now suppose we are removing some more material from the workpiece, then it will take new position from point number 1 to, let us say, point number 2 prime. It will come with rapid traverse again, fast, then 2 prime to 3 prime with some feed again, then again some feed, 3 prime to 4, then 4 to 1 again. So it will start from point number 1 and it will stop at point number 1, and with just one line of information it will execute 4 distinct moves in a single G90 code cycle. Now here one question may arise is that what is the difference between using G01 code and G90 code, because from both the codes we are removing the material from the workpiece. So with G01, that is by using linear interpolation code, we have to write all these line of informations in our program. So our program will consist of 4 lines when we are moving from point number 1 to 2, 2 to 3, 3 to 4, or 4 to 1. We have to separately write all these lines in our program. But when we will use G90 code, there is no need to separately write all these 4 distinct moves. We will simply write G90 X value, Z value, and some feed value. It will execute all these 4 moves with just one line of information. So with this, we have shortened the program also. So this is the advantage of using G90 cycle. So I hope now it is very much clear to you that how material will remove with the help of by using G90 cycle. This is the syntax for G90 code, that it will have to provide us X value, Z value, and feed value. And X represents what? Diameter. Z represents the length. And F represents the feed. Now, let us now write our program for this G90 cycle. So this is the part drawing for which we will write our today's program. The outside diameter of the cylindrical workpiece is 25 mm, and now we will reduce this 25 mm diameter up to 21 and 15 mm diameter, and the respective lengths are given here: 14 mm, 12 mm. The total length of the workpiece is, let us say, it is 70 mm. So this is the starting of our program from here to here. Now, those who are watching directly my this video lecture, I recommend them to kindly watch my previous video lecture, that is lecture number 4. The link is given here on the top of the screen. You can press the I button. There you will find my previous video lecture. And I had explained in a very detailed way the starting of our program. Today, I will explain the starting of the program, not in that detailed way because I had already explained it. So kindly watch my previous video lecture who are watching directly my this video lecture. So this is the starting of our program, and we know we are writing this program for FANU controller. And in our FANU controller, our program starts with letter O. This is the letter O, and these are our 4 digits, 1002. So this is a program name. After that, we have initial settings G21, G98. G21 for input in mm, because the dimensions are shown here in mm. In case of dimensions, let us say you have a part where the dimensions are shown here in inches, let us say, then we will use G20 code here. Then this is feed. G98 is a G code for feed in mm per minute. In case of feed in mm per revolution, we will take here G99 code. Now, after that, we have G28, which is a G code for home position. Then we have M06, a machining code for tool change. T is the tool function. After T, the first 2 digits represents the tool number, and the remaining 2 digits represents the tool length offset. Then we have M03 code, which is a machining code for spindle rotation in a clockwise direction. S is a spindle function, and 1200 is the RPM. So the meaning of this line is that we are rotating the spindle in a clockwise direction with 1200 RPM. After that, we have G00 X24 Z5, means we are moving the cutting tool from the home position at this particular location X24 Z5. So this is the entry point. Okay, so initially we know, let me draw this particular position for you, or this location X24Z5. Initially our cutting tool will be at its home position, we know. Okay, so if I extend this line, this is X25 line, and this will be our Z line. We know at this particular point, here we have plus Z. Away from this point is a plus Z movement. This will be our plus X movement. From this point, if we are moving inward inside, it will be our minus Z movement, and this is our minus X movement downward. Okay, so at the center of the workpiece, our X and Z values are 0 here. So let me just locate this location for you, X24 and Z5. X24 means it will be below the 25. So let us say this is 24 line, and Z5 will be 1, 2, 3, 4, 5. So at this particular location, let us say here we are reaching from home position to this particular location. So we are moving with rapid traverse, and this is the location X24 and Z5. I hope it is clear to you now. After that, we will use G90 code, that is box turning cycle, in order to remove the material from the workpiece X24, Z-26, and F80. So let me explain you this line of information or this block. X24 is the diameter because we are now removing the material from the workpiece. So X25 to X24, this is the diameter value. Then this is the length value. Because we have 14 plus 12, it becomes 26. So now from here to here, the length will be 26. Since we are moving towards the spindle, so it will be our negative Z moment. That's why we are taking minus 26 over here. And F is 80 mm per minute because we are using code G98 here. In case of code G99, we will use here feed 0.08 mm per revolution. So there is a relation for mm per minute with mm per revolution. You can convert, that is 1 mm per minute will be equal to 0.001 mm per revolution. And in case of 80 mm per minute feed, we will convert it and it will be 0.08 mm per revolution. Okay. Now what will happen when we will use this G90 cycle? It will start from this particular point at X24Z5. It will remove 1 mm material from the workpiece and stop here also. As I had explained you earlier, that it will, let us say this is the position of X24 and Z5. So it will move 1 mm downward, then it will remove the material. It will go up with some feet, then come back again and stop here. Okay. So with just this one line of information, it is executing 4 distinct moves. There is no need to separately define now each and every movement of the cutting tool. So this is the difference by using G90 code with the G01 code. Now after that, we will reduce this diameter from 24 to 23. And there is no need to give once again G90 code because this is a model code and it is active in the memory of the machine's memory. After this, we have X23, which means we are defining the second depth of cut now from 24 to 23, then 23 to 22, and then 22 to 21. So this figure shows that we have removed this much material from the workpiece till now. Okay, and the diameter for this outside diameter for this cylindrical workpiece was 25 mm, and we have removed 25 mm diameter up to 21 mm diameter, and the length was how much? 12 plus 14, it was 26 mm. Okay, now when we will reduce the diameter from 21 to 20, let us say this is 20, now we will move the cutting tool up to the length of how much? This length is how much? 14. So this is 14 mm. So now we are changing the length from 26 to 14 mm when we are reducing the diameter from 21 to 20. So that's why we are using once again G98 code here, and X we are taking 20, then Z we are changing here -14, and feed we are taking same. If you want, you can change the feed, but we are not changing here. So I hope now this line of information is clear to you. After that, now there is no need to write again and again G90 code. We will simply change the diameter value. Okay, so from 20 to 19, then 19 to 18, 18 to 17, then 16, and then 15. So it means that we have removed this material also right now, and we have got the desired profile for which we were writing the program. Then after that, this is the ending of the program from here to here. So G28 U0W0 means back to home position. So we are keeping the cutting tool at its home position after getting the desired profile. This is M05 machining code for spindle stop, M30 program stop and rewind. So this was the program for G90 cycle, that is for box turning cycle. Now let me show you the same program in a simulator for better understanding. So this is our CNC train simulation system, and you can see here on the left hand side the same program is written which I was discussing with you. Now let us try to simulate this program here. Let us run the program. Start. Now the cutting tool will come from its home position at a desired location. Now he is removing the material from the workpiece and keeping the diameter as 24. Now this is 23 mm diameter, 22 mm diameter, and 21 mm diameter. Now after 21, see, it will change the length. See, this is a 20 and length is changing. Okay, this is 19 mm diameter, 18 mm diameter, and this is 17, and it will go up to 15. This is 16, and now the last depth of cut, that is 15 mm diameter. After that, the tool will move back to its home position. Now, I hope this video lecture is very much clear to you that how to write a program by using code G90, that is for box turning cycle or simply for a turning cycle. And you know the advantage of using G90 cycle is that by using G90 cycle, it will execute 4 distinct moves with just one line of information. And if you still face any difficulty in this video lecture, then you can comment me on the comment box of this video lecture, or you can directly email me on my email ID, which is mentioned here. So thank you so much for being with me in this video lecture. Now let us meet in our next video lecture. Thank you.